Okay, let's try this again. Take two. Take two, nerds. Let's try it again. All right. We're going to solve by elimination today. And it's called elimination because the goal is to get rid of one of the two variables, literally eliminate it. What? Oh my God, what are they doing over there? What is happening? Let go of his pen. Stop playing with his pen. Save that for the locker room. There we go. All right. Okay. So we're trying to eliminate one of the two variables, and your job for elimination is very, very simple. When one of the variables, either the x or the y, has the same digit in front of it for both equations. For example, in this setup right here, both of my x's have a 6 in front of them. Life is good. It's very, very easy because I can eliminate these x's without doing any multiplications or anything like that. I mean, if I have a 6x and a 6x, what kind of operation will get me a 0 x's? Subtraction. So what we're going to do is put a big, obvious, ugly minus sign out in front. And you notice I put it between the two equations. I don't want you to put it in front of this negative, in front of the 6 and call it a -6. No, no, no. No, I want you to have to reference this big, ugly minus sign every single time. And I want you to literally say the operation in your head like this. 6x minus 6x, yes, that gets me a 0 because that was the idea. You needed it to get you 0. And the reason why I'm asking you to reference it and point at it when you do it is because of this. Anytime you see a double negative, anytime you see minus negative, I need bells and whistles going off in your brain thinking that's addition. So this actually says 4, and I know they're both y's, so I can even get away with not saying the y. 4 minus -1. And then you think, oh, but minus negative means what, guys? Well, addition. So what we have here is 4y plus 1y, giving me 5y. I need another piece of paper. It's not going to work out very well. The pen won't work well on the table. And then this one, -10 minus 10, -20. If you go through the process of actually referencing it every time and saying the words in your mind, you're probably not going to miss these minus negatives and things like that. Then just divide. Gets us y equals -4. Just like yesterday, now that we know what y is, we're well, really more than halfway done. All you have to do is plug that y value into, well, either one of these. It actually doesn't matter which one you choose. Just plug it in one of the two and get x by itself, and you're finished. Just like yesterday. We're solving for where two straight lines intersect each other. We have the y value. Let's get the x. Numbers are smaller in the second equation, so I'm going to go with the second equation. 6x minus, I'm going to use a set of parentheses because I'm substituting. And I suggest you do the same thing. And what was it, y? -4? Oh, look, minus a negative. We get to talk about it again. Minus a negative, that means add. So what I really have here is 6x plus 4 equals 10. Just get x by itself. Subtract 4 from both sides. 6x equals 6. I don't think I need to show it, but divide both sides by 6 to get that x equals 1. All right. That is an x comma y. It's a coordinate where my two straight lines intersect at 1 comma -4. Like I said, this is Algebra 1. It's literally Algebra 1. I'm doing nothing new. Nothing. Do you have anything at all that you'd like to ask me about this setup, this process, any of that stuff? I'll give you some think time while I pause the video. Is wait time, has it been uncomfortably long yet? A little bit? Yeah, what's up?
So if the number in front of the variable isn't exactly the same, we can't eliminate it?
Not the way it sits. So we can't use elimination unless the numbers, the digits match. And I'm saying specifically the digit because I don't care about the symbol with the plus or the minus. That's not important. I just need the digits to match in order for me to be able to eliminate. Okay. Now, can you create a third equation? Sure. Like if let's just say the x's didn't match, I still could have subtracted and I would have had a new linear equation. And that new one, if my brain is braining properly, would also intersect in the exact same place that these two would. And now that I've said that, I think I want to give that a try when I'm finished with the notes, because I'm pretty sure that's what would happen. Interesting. I never really thought about that. It's one of the reasons why I love teaching. So every now and then somebody says something that really puts a question in my mind. I'm pretty sure if they don't match, we could still solve by graphing. But if we subtracted or added them, we would have a whole new equation, and I'm pretty sure it would have to go through the exact same point of intersection. I won't put it in the video, but I'm going to try it myself because it's interesting now. Thank you for that. But yes, in order to do true elimination, we need the numbers to match. For example, in this equation, neither the x's nor the y's has the same digit in front of it. So you just pick one to eliminate and do what we have to do to make them have the same number in front of them. And that is multiply by something somewhere. It doesn't matter which one you choose to eliminate, x's or y's. So, because x's come first in my answers, I'm going to go ahead and eliminate the y's. That way the first answer I find is x. And that's the only reason why I'm saying that it doesn't matter. You just pick one and go with it. Who cares? So what I'm going to do is I'm going to attack this one because what I see is that in front of its y is a 1. And we like that because a 1 can be made to be any other number through multiplication. I can make it have the same digit as this one just by multiplying everything by 4. Come over to the side because I want these things to be stacked so I can use elimination. Once again, I'm multiplying this bottom equation by 4 because it's going to put a 4 in front of this y, and then my y's will have the same digit in front of them. I have pin marks all over my hand. You see that? Look at this crap. Look, we've been fighting with these things today. Anyway, the top equation is unaffected. 6x plus 4y equals negative 12. After the distribution, the bottom equation becomes 8x minus 4y equals 40. My y's now have the same digit in front of them. Notice that I didn't care what symbol was associated with the y. If that makes you uncomfortable, if your Algebra 1 teacher taught you, multiply by whatever it is that you have to multiply to make sure that one of them is positive and one of them is negative so you can always add. If you want to do it that way, then do it that way. I don't do it that way because I don't think ahead very well. So I just like to go, let me make the numbers match, and then once my numbers match, I'll decide if I should use addition or subtraction. That's just how I've always done it. And if you're uncomfortable with it, then you use a method that you are comfortable with. I don't mind if you do something different from what I do. Now, I have a positive 4 and a negative 4. Would adding them or subtracting them get me 0? Adding. Because 4 plus negative 4 gets me 0. And that's why I'm going to put a big plus sign out here, like so. And I'm going to add straight down. Devil's advocate. What if I had tried to do subtraction? You would have said 4 minus negative 4, which would have forced you to think 4 plus 4, which isn't 0. You needed 0. 6 plus 8 is 14 of these x's. Negative 12 plus 40 is positive 28. So the difference between the top system and the second system. Here, the digits and the symbol were the same. They were both positive. So it made me subtract. Here, the digits were the same. Well, I pointed the wrong place. Here, the digits were the same, but the symbols were not. So you add. If you want to always add, then you'll have to make sure that one of them stays positive while the other stays negative. That's on you guys. I don't ever care to try to make those kinds of things happen because I'm comfortable saying minus negatives and pointing at my symbols as I use them. Anyway, let us divide by 14 on both sides, which will give me x equals 2. And would you believe that that's the first time today, even though I've done this 3 times, that's the first time today that I wrote divide by 14? The other 2 times I wrote divide by 2 because I knew that was the answer. I did it 2 class periods in a row. It's hard to think, talk, and write all at the same time. Drummers, am I right? It's tough, right? Operating multiple systems at one time, doing different things. Drummers and piano players. Anybody play the piano in here? You do? So piano player is the same way because their 2 hands are doing something different than their feet, which is really interesting. Drums and piano is a very global brain operation. It uses like everything that your body can do. All right, we got x equals 2. It doesn't matter which equation I throw this x equals 2 into. In fact, someone asked me earlier today, could I put it into one of these two? Yeah, you can. It doesn't matter. This one, or this one, it doesn't matter. Put x equals 2 in there and get y by itself. I'm going to go with that one, and that's just because I don't want to divide by negatives, because I don't want to accidentally miss a negative somewhere, because that's really easy for students to do. So we go 6 times whatever the heck x is, plus 4y equals negative 12, and we found x to be 2. Go Gators, orange and blue. 6 times 2 is 12. Get y by itself. Subtract the 12 from both sides. Plus, if I do it this way, it gives me the opportunity to remind you that when you have a negative and then you say minus more, you don't have to say minus. You could say negative 12 and also negative 12 more. Maybe that helps you think and, which will give you negative 24. Ilya, what's up?
What do we just leave the 4 that we used in the very original problem? Like when we have to multiply 2x and minus y by 4. Do we just leave it?
You mean this equation? Am I doing nothing with it now?
Yeah.
Yeah, I'm not doing anything with it. Nothing. It doesn't matter anymore. That is this 8x minus 4y equals 40. I could have plugged x equals 2 into that. No. All the 4 does is allow us to see another version of the exact same equation. So no, it doesn't actually do anything. It's just there. It manipulated the way the equation looked, but it didn't actually change the equation. So this original 2x minus y equals 10 and this 8x minus 4y equals 40 are the exact same line. We've just manipulated the way it looks. It's like saying 2 over 4 instead of 1 over 2. It's the same number, but we've changed the way it looks, if that helps. Divide both sides by 4, and we get our y value of negative 6. And just like before, we have found an x comma y, a coordinate pair where these two lines are in exactly the same spot at the same time, 2 comma negative 6. Boom. In today's examples, there are none with infinite solutions and there are none with no solutions because it's kind of redundant. When you're solving systems of equations, if you get a true math statement like 0 equals 0 or 3 equals 3, that's infinite solutions. If you get a false statement like 0 equals 1 or negative 2 equals positive 2, that's no solutions. So I just didn't put it in today's notes because you saw it happen yesterday. It's kind of redundant. It's the exact same process. The last equation for the day, and then we call it, and you guys can just tackle the homework. Oh, by the way, I got to show you the answers to the homework so you can check your work. And I have to give you a hint on the last homework question, number 10, is this equation right here. In this equation, once again, neither the x's nor the y have the same digit in front of them. And also, neither one of them has a 1 in front of it. So I can't just say, oh, I'll just multiply this one equation by a number to make my x's or my y's match. Because of that, what I'm going to have to do is I'm going to have to multiply both equations. Is it a question about this, or are you just going to say? We just got to multiply both equations. And again, it doesn't matter which one you're trying to make match. Make the x's match. Make the y's match. Whatever, it doesn't matter. Pick one. Just pick one and go with it. And because I know my answer is going to be x comma y, I want to get my x's first, because that's just a me thing. I just prefer to get my x's first. That means I'm going to eliminate my y's first. One of them has a 4 in front of it. The other has a 3 in front of it. I'm trying to make them be the same number. 3 and 4, what's the smallest thing that they could both become? They could both become 12. That's the smallest thing. Is it a coincidence that that's what happens if you multiply this by 3 and this by 4? No. The reason why is because 4 and 3 do not have any common divisors. Since they have no common divisors, we're stuck with just multiplying them by each other. But, a bunch of people are working ahead, but 6 and 4, they do have a common divisor. So I don't have to multiply the top equation by 4 and the bottom equation by 6 if I want my x's to match. Could I still? Sure. So why not just always do it that way? Big numbers, bigger fractions that need to be reduced. That's the only reason why. But just so you know, 6 and 4 do have a common divisor. So 24 is not the smallest thing they could both become, which is 4 times 6. The smallest thing they could both become is 12. So by coincidence, both of them are 12s. But I was just letting you know. I feel like it's easier to go with the smallest stuff, but you don't have to. Okay? Anyway, multiplying the top one by 3 and the bottom one by 4. Notice I didn't give a crap about the sign in front of the digits. I'm just trying to make the digits match. That's just the way I like to do it. If you prefer one always be negative and one always be positive, then by all means, make that happen through the multiplications. I'm a fan of making the digits match and then looking at the symbols and figuring out should I add or subtract. Distributed 3 across the top here, and what you get is 18x plus 12y equals 3. Distribute a 4 across the bottom, you'll get 16x minus 12y equals 48. My y's match. One of them is positive 12, the other is negative 12. I need to combine them. Would adding 12 and negative 12 or subtracting get me 0? Only 2 people answered. I sure hope everybody in the room knew that it was add. Holy cow, I hope that everybody in the room knows that 12 and negative 12 gets you 0. Treat the plus sign as an and if it helps you. What you end up with here is 34x, yes, that gets me 0, 12, and negative 12, equals 51. And we're going to divide both sides by 34. If you grab a calculator to see what 51 divided by 34 is, you're going to get a decimal. I want my answer in fractions. Luckily, the decimal is pretty. The decimal is 1.5. That's because 51 and 34 are both divisible by 17. But as long as you know that 1.5 is 3 divided by 2, we're in good shape. Because like I said, my answer on my test would be a fraction. It would not have been 1.5. Now take your x equals 3/2 and go to any of our 4 equations, plug in x equals 3/2 and get y by itself. It doesn't matter which one you choose. I'll go with the top one. Why not? 6 times whatever x equals. And x happens to be 3/2. 6 times 3 is 18. And 18 divided by 2 is 9. Just get y by itself. Divide by 4. And this easy, quick lesson is finished. All we have to do is write this as a coordinate pair. 3/2, comma, -2. And we're finished, nerds.